All right, so here's problem number 23. They start off by telling you that x cubed plus 729 equals 0. Well, hopefully you can see right away that this is a sum of two perfect cubes. In fact, that it's x cubed plus 9 cubed equals 0. And so here you need to take advantage of those expansion formulas I told you to memorize, especially with the sum of cubes. So if you had that formula memorized, you could plug it in like so. You would have x plus 9, parentheses, then you would have x squared, then you do the opposite sign, so you'd have 9x, and then you'd have always positive 81, which is 9 squared. And now that equals 0. So we've expanded this. This means that x plus 9 equals 0, and that x squared minus 9x plus 81 equals 0. So you have one solution here really easily. It's just x equals negative 9. Over here, though, this one is not so simple, because in order to find this one, you're going to have to use the quadratic formula. So when you plug that in, it should look something like this. You get x equals positive 9, because it's a negative b, so negative 9 makes positive 9, plus or minus b squared, which is going to be 81, minus 4 times your a term, which is just 1, so don't really need it, times your c term, all over 2a, which is just 2. And when you work this thing down, end up with x equals 9 plus or minus 9i rad 3 all over 2. And that's your other two solutions. And I say two solutions because, look, there's a plus or minus there. And so that represents two different solutions. Okay, they ask you to solve this one. Well, first thing, we need to get it equal to 0. So let's add that 60 to both sides, make it equal to 0. And then we need to rewrite this so that it looks like a quadratic. Well, this term here is always our hint. We need it to look like this term. So let's just do that. Square root of y squared. Well, does that equal that? It does, right? So we're good. We could just write it like that. Minus 9 square root y plus 60 equals 0. And now we just need to factor this thing. So we'll put the 60 on top. We'll put the negative 9 down here. We ask ourselves what multiplies up to 60 but adds up to 9. And I just realized that I made a horrible mistake throughout this whole thing. This is supposed to be a 19, that's supposed to be a 19, and that's supposed to be a 19. So that means this is supposed to be a 19. So really we want to know what multiplies up to 60 and adds up to negative 19. Well, that would be negative 15 and negative 4. So we could write this as square root of y minus 15 times the square root of y minus 4 equals 0. And then we could break this into two different equations. One where we have the square root of y equals 15 and the square root of y equals 4. Square both sides and you get that y equals 225 and y equals 16. There you go. Okay, for number 31 on this homework, I realized that I didn't really give you the skills to answer this question. So this is the work that I did to do it. I'll kind of briefly talk about it. Let's say you have some prism here. Let's see if I can get this drawing to make sense. Okay, and they told you that the width here is w. Then they said that the height is 2 less than the width, and the length is 4 more than the width. So that means that your volume is this times this times this, or this expression that I have up here. And they also told you that the volume is actually 8 times the length. Well, the length is w plus 4, so you could just do 8 times w plus 4. Well, what I did is I saw there's a w plus 4 over here and a w plus 4 over here, so I divided it out of both sides. Now, this is just kind of a shortcut technique. When you do that, you end up with 8 equals w minus 2 times w. Since I divided by w plus 4, I know that, just making a little side note, I know that negative 4 can't be w, because if it was, I'd have a 0 in the denominator and this would all fall apart. So I know that can't be. Now, once I do this, I'm going to distribute the w, get w2 minus 2w, and subtract 8 from both sides, so I get this thing. Well, that's pretty easily factorable, because -8, -2, -4 times 2 makes -8, -4 plus 2 makes -2, so I could factor it. And that means I could break it down into two solutions, one where w equals 4, one where w equals -2. Well, I can't have a width of a negative distance, so this one doesn't work, so this must be my solution for w. And then, of course, you could just plug that in and get your other dimensions, right? So your length would have to be 8, and your width would have to be 2, and yes, your width is 4. So that's all you really got to do for that one. I know it wasn't really one that I explained, but there is a way to do it. Okay, for 32 and 34, they give you this picture. It's a frame. They say tell you the size of these frames is x squared minus 3 and x squared minus 3. And then inside that they say that, there's a little mirror, and that's just going to have dimensions of x by x. So they also tell us that the total area of this pink part is 27. So we got 27, cubic or squared inches. All right, well, they want us to get a function that represents the area of the frame, so the area of the pink part. So let's do that. We know the pink part is 27. We also know that it would equal x squared minus 3 times itself, right? Because that's this whole distance, and then or this whole area, and then we could subtract out this area, which is x squared. So we could do a little box over here on the side, figure out what x squared minus 3 times x squared minus 3 would be. It would be x to the 4th minus 3x squared minus 3x squared plus 9. So we could write that over here. 27 equals x to the 4th minus 6x squared plus 9. And then remember, we have to subtract out this x squared. And really, in any function, we want to get it equal to 0, so we also have to subtract this 27. So that means we would have 0 equals x to the 4th minus a 7x squared, because you have 2x, or you have a negative 6x squared and a negative 1x squared. And then 9 and negative 27 makes negative 18. Okay. So now we have some stuff that's factorable. Let me move some of this stuff out of the way. Okay, so we're going to ask ourselves, can I factor this? Well, can I go negative 18 and negative 7? Also, remember, I should probably write this as a quadratic, so I'd get x squared to the second power minus 7x squared minus 18, just so it looks like something that I could actually solve. My factors would be, let's see, what multiplies up to negative 18 and adds up to negative 7? I think a 9 and a 2. Right, 9 and 2, and let's make it a negative 9 and a positive 2, and that seems like it'll work just fine. So that means we could say, hey, 0 equals x squared minus 9 and x squared plus 2. Sorry, I got to move it out of the way so I can keep working. This is a perfect square, and this is a perfect square, so that means I can expand this as 0 equals x plus 3 and x minus 3. And this one's not a perfect square and a perfect square, so this is x squared plus 2. So I can write a few different equations. I could write that x equals negative 3. I could write that x equals positive 3. And I could write that x squared equals negative 2. This one over here is only going to give me imaginary solutions, so I'm not really interested in that. So we can cancel that out. And I'm not really interested in negative distances either. So it looks like my x is just going to be 3. So let's go back to the original picture. Well, my x is 3 here and 3. Fill that in. So this is 3 by 3. That would make this 3 squared, which is 9, minus 3, which is 6. So this is 6 by 6. And that's all your answers for 32, 33, and 34.